Welcome students. In this video, we will be discussing about the implementation of creating linked list using insert method. Already the concept of how to create a linked list using insert method, we have already discussed it. Now we are going to into the implementation of the same. Right? So I'll just directly enter into editor. So where we already have both the recursive as well as the iterative approach of inserting the node. Now we are going to we are going to write one more method. We're going to write one more method, and let us have the return type void. If required, we can change it. Okay, so this is like create linked list. Create linked list is a create linked list. Okay, creating linked list is a okay. So coming to this create linked list method, right? So let us start with it. So the very first thing is that create a pointer, create a first pointer, create a first pointer having null, store it with null. And now just write a loop. Let us consider that 5 elements that we are going to insert, 5 elements that we are going to insert. So let me write a loop for 5 times, that is going to run for 5 times. So I is equal to 0, I is less than 5, I plus plus. Yes, this loop will be running for exactly 5 number of times. And what we will do is we will also take a variable to receive input from user, int x. Now inside this loop, let me write scanf %d comma ampersand x. This method will be receiving an integer input from user. Okay, fine. Now what we need to do is we need to call the function insert node. The iterative approach I'm calling. And now insert node, what we will have to pass is that first of all pass the address of the first node which is available in the pointer first. Next one is the data to be inserted is x. Then the third argument is insertion point, that already as discussed it should start from 0 1 2 3 4 5. So whatever is the index loop variable value, that is going to be the insertion point. Okay, but while you call this function will be returning you with the address of the first node which you again receive with the help of the same first pointer. So first is equal to insert node of first comma x comma I. Right, fine. So after coming out of all these things, let us call, I think display function is available here. I think the recursive approach is available here. So let us call that r display function and check after the creation. We will provide the address of the first node. Sorry, after creation we will call the r display function, and let us pass the address of the very first node, that we are passing. And let us check things are working properly. See, we are not writing anything much. We are just calling the insert method, but we're calling it for 5 times. Every time the data and the insertion point we are changing, as we discussed in the previous video. Now we will just execute this and check. Instead of create, let us call the function create linked list and check whether things are working properly. So in the execution, we should be giving 5 elements as the input. Even we can make it dynamic with instead of giving 5, we can also have it dynamically also. Receiving a value x and checking whether it is not equal to 1, the same, not equal to -1. The same technique also we can use if we want to do it dynamically. But here we will just check whether it is going to work properly or not. So we will just compile it. No syntax error. Execution. So let us enter 5 elements. Okay, so the 5 elements are going to be 56, 12, 89, 34 and 60. 5 elements. So let us press enter. Are you able to see? Again the same 5 elements are coming back. The reason is the same calling insert method. When you call insert method with a different insertion point starting from 0 and different data, is actually creating a linked list. So insert method also can be used. It can also be used to create a node, but whether it is going to be efficient or what, we will see it in the next video. We will discuss about that in the next video. But here the main thing that we need to understand is the insert method. Using insert method, how to create a linked list, right? How to create a linked list, right? So now we'll also convert this create linked list into recursive approach. Not only insert node is going to be recursive, this create linked list also we will try to make it as a recursive code. Just convert the same thing into a recursive approach. Okay, so what we will do is that first of all we will just take this struct node star first is there, right, available. Let us make that as a argument, and also let us make this x also as an argument. So whatever data required inside, we'll take it as an argument. Okay, so x is also taken as one of the argument. Okay, fine. Next, loop only, what you are going to do, this loop only we are going to convert it into we are going to convert it into recursive approach. We're just going to convert it into recursive approach, right? Fine, right? So what we have to do is, first of all, if the condition, the same condition we will take. Where is I actually? I also we need to make it as an argument. So int I, that also we will make it as argument. Now what we will check is if I is less than 5. The same thing that we are just changing it. If I less than 5, I'll open a block. Whatever we have done, first of all, scanf we have done, right? So what you will do is we'll just use scanf. Okay, I think what we can do is that simply, I think first element you will receive here. First element you will receive here. Am I right? First element you will receive here. First element you will receive. So what I will do is, first of all, we will execute this line. We will execute this line. Okay, 1 minute, 1 minute. Okay, so here inside this, what we will be doing is we'll be calling this line actually. First is equal to, okay, first is equal to insert node of first comma x comma I. Okay, insertion will happen, and it will return the address of the first node which we are storing in first. We have a possibility of this first pointer to have changed. So after that, what you have to do after doing this insert node, what you should have done, we should have just called the same function again, right? We should have called the same function again, but before that, let me do scanf. See, why I'm doing scanf second is that because while calling itself, some data you could have started passing base, the first data. So that's the reason why I'm not, starting with, we're not starting with the element actually. We're not starting with the scanf. We're just making the scanf the second statement. Okay, so scanf %d, comma, ampersand x. Now, after both these lines get executed, let me call the same function again, create linked list. Same function. There is a possibility of first pointer to have changed, right? So let me pass the first pointer, whether a new whether new address or existing address, no matter whatever it is, but pass instead of first argument, pass first. Second one. I think because of this scanf statement, x also could have changed. So pass the new x, comma I. What you should have done, instead of, see, there in the loop you are here in the loop you are incrementing it, incrementing it, right? Similarly, while you're calling it, you have to increase the value of I by 1. So this recursive call will actually do the same process of this for loop, right? So after this completely getting executed, after completely, if this is not, see, if this is true, then you have to carry out this. If it is not true, else. If it is not true, come to else and just call the rDisplay function and pass the address of the first node. Pass the address of the first node. Right? So let me get rid of this, and also along with rDisplay. So now we have a new function. Okay, now we have a new function. We have a new function where it is completely implemented with the help of recursion. But before that, I think we lost our iterative approach. So let me make another copy of it. Okay, let me make another copy and we will just completely change it again. Okay, so changing it means scanf, again taking it and placing it here. Iterative, because we also want iterative approach to start our time complexity and space complexity analysis. So all these things will not be here after the argument. So all those things have to see. 1 minute. All these things will become the okay. Very okay. Fine. So it is okay first, and then we have variable x and this loop variable that we will decide later. So first is equal to see struct node star first is it is equal to null by default, is equal to null by default. X we are declaring, and let us write a loop for int I is equal to 0, I equal to 0, I less than 5, I plus plus. Inside this loop we have to be placing scanf and these two conditions one after the other. Okay, one after the other, and this if condition completely will take. After that we will be calling this R display. That's it. This is what the iterative approach that we have already implemented. Just I have just reverted back the code. That's it. Right? Fine. So now when you call this, it was actually working fine. Now we are about to call this new method called as R create linked list new function. Okay, so now let us call this function and check whether it is working properly. But here, coming to the main method, now we are calling R create a linked list, but the arguments are going to be, right? That the argument is very important, right? The argument is going to be like, first of all, the very first pointer is argument is pointer. Pointer is the very first argument. Okay, yeah. So it is the address of the first pointer. Initially, there is no node at all, so null we will be passing. The next one is actually x, data x. 1 minute, guys. The next one is actually the data x. So the data x, let us take it as initially, let us start it with 15. Next one is, the next one is actually I value. I value, what we have to do, we have to just start it with 0. Right? We'll just save it. And how many elements, and it means how many elements that we have to be giving here. I think we should be giving a total of 5 elements. I think we will be giving it. 1 minute, we will just check how many elements we have to provide. First element we provided there, and here what we are doing, we're just checking I less than 5 and inserting, then receiving an element, inserting and then receiving element. I think this is not required if it is a last node. Am I right? It is not required if it is. See, one thing that we will do, instead of passing the element, okay, instead of passing the element from the main function, we will place scanf here. We'll place scanf before. Okay, we will place scanf before before insertion. Okay, similar to iterative approach, we'll place scanf before insert node. But here, when you're just sending, this is going to be just a dummy value. This is a dummy value, because whatever value you send before inserting it, this scanf will be working and it will receive a new data from user, and then it will go for insertion. So whatever we are sending here is going to be just a dummy data, right? So now after calling this function, now let us check whether it is working properly or not. We'll just make it sure whether it is working or not. Okay. I think both methods are having same name. Is it right? This is create linked list or create linked list. And is there any other okay, so let us just look into the error. What is the exact error? Okay, while calling we are not, I think while calling also we are doing this. Okay, okay, I think the recursive call, whatever we are doing, is not an S. The recursive call also should be the same name, right? R created linked list. So that's what the mistake we are doing. So name of the function. So now again we will go for okay, compilation successful, execution. 5 elements, 12, 23, 34, 45 and 56. Yes, you get the same answer back again. So both ways you have implemented the new creating linked list using insert method. One is your recursive approach, also we completed create linked list recursive approach. The other method is actually the recursive approach also we completed. So two methods we have implemented here. One is recursive, the other one is iterative, right? Fine. Okay, good. So in the next video, just come back to look at the discuss about time and space complexity analysis of both this iterative as well as the the recursive approach, and also we're going to do it a little bit, like comparing it with the old create method also. So I think we already know the time complexity of the old create method, which we will be comparing it with this. So we'll be comparing which is going to be the best one, which one we should prefer, right? Thank you, students.